Okay, one last short video that will go along with our first lesson on evaluating limits graphically and numerically. We just need to examine when limits exist and when they do not exist. So we have what we call the limit existence theorem, and basically it says that if f of x becomes arbitrarily close to a single number L, as x approaches we'll say as x approaches c, which is some number, from either side, the limit of f of x as x approaches c is L. So basically this is saying that as we approach some value c from both sides, from either side, and if on both sides we approach a number from both sides, that number is the same, then that number is our limit. So let's look at an example. Part A says, as x approaches 2 from the left. So we want to trace our graph coming closer and closer to 2 from the left. And it appears this graph is approaching infinity. All right, so then as we approach 2 from the right, it's also approaching infinity. The problem here is that infinity is not really a number. We can't say infinity would represent our L in our limit existence theorem. It is approaching the same thing, or has the same behavior from both sides. So it's not wrong to say that the limit as x approaches 2 for f of x is infinity. However, since infinity is not a number, we technically say this limit does not exist. Okay, because we're not approaching a specific number from both sides. Infinity is not really a number, it just describes a behavior. Okay, so I don't want this to be confusing, and it can be at times. It's not wrong to say the limit is infinity, but the limit technically doesn't exist. It's approaching infinity, but since infinity is not a number, technically.
Teachers, at this time it is.
Oops, sorry about that little interruption there. I'm trying to record this during course lunch on Thursday, so this period, and so that's what happens. But anyhow, as I was saying, that the limit, we can't express it as infinity, but it still technically does not exist since infinity is not a number. Now, f of 2 means what is the y value when x is 2? So this is looking for a function value, not necessarily a limit. And at 2, there's a vertical asymptote, so this y value is undefined. Okay, let's look at another example. Here, we want to again approach 2. So we're going to approach 2 from the left, and it looks like we're getting closer and closer and closer to having a y value of 2 as well. Then when we approach 2 from the right, once again, we're trying to approach a y value of 2. The left and the right hand limits are the same, and 2 is a number. So does the limit as x approaches 2 for f of x exist? Yes, it exists, and that limit is 2, and that is because the limit as I approach 2 from the left is the same as the limit as I approach 2 from the right. So that's how we can say it exists, because the left and right hand limits are the same, and it is a number. Now, f of 2 means what is the function value? What is y when x is 2? And now we need to look at the closed dot. So actually the answer to this one would be 3. So the function value and the limit are different in this case. Okay, one more example here. This time we're still approaching 2, but a different graph. As I approach 2 from the left, I'm going to trace my graph, and it looks like I'm trying to get to a y value of 3. As I approach 2 from the right, looks like my y value is negative 3. So I would say that the limit as x approaches 2 for f of x does not exist, and that is because the limit as x approaches 2 from the left of f of x does not equal the limit as x approaches 2 from the right. So if the left-hand limit and the right-hand limit are different, or they're not a number, then the limit will not exist. Again, the function value is what is the y value when x is 2, and we want to find the closed dot. So that's 3 here. So in this case, the function value and the left-hand limit are the same. Okay, so hopefully that clarifies a little more about when a limit exists and when it does not. The rest of the notes go over some examples. It just has more practice in it, but hopefully from these notes you can review these videos to help you understand more about determining limits graphically and numerically. Don't forget to do your homework that goes along with this lesson.